In this video, we're going to look at the law of sines and the law of cosines. So let's first look at the law of sines. So when we have triangles, normally we use trig to solve for missing sides and missing angles, but this is for right triangles. The law of sines and the law of cosines enable us to find missing sides and angles of triangles that are not right triangles. So if I've got an acute triangle, an obtuse triangle, any triangle that's not a right triangle, I can still use trig to find the missing sides and angles, but not in the traditional way that we've used it for the right triangles. So let's examine the law of sines first. And so the law of sines is made up of a set of ratios. So if I've got a triangle and I've got this is angle A, that's angle B, and that's angle C. The sides opposite are the lowercase letters. That's little a, little b, and little c. So what the law of sines enables us to do is to create a set of ratios so that we can solve for these pieces and these components of this triangle that's not a right triangle. So let's look at the law of sines. Now that you have your triangle, here's what the law of sines says. It says that the sine of angle A divided by the length of side A should give you the same ratio as the sine of angle B divided by the length of side B, which in turn should also give you the same ratio as the sine of angle C divided by the length of side C. So what you want to do when you use the law of sines is you need to have three and solve for the fourth. So you're not going to have this big equation here with three terms. You're going to pick two only because an equation is going to be like setting up a proportion. So let's do a sample or an example. Let's say I have a triangle here, and I'm going to say this is angle A, and this is angle B, and this is angle C. Now, I'm going to give you angle A. I'm going to say that angle A is 40 degrees, and the side across from A is 10 centimeters. I'm also going to tell you that angle C is 70 degrees, and I want to know how long side C is. So I've got two angles, one side, and one side that I'm looking for. So I have three of the four components I need to set up the equation. So I'm going to pick, in this case, I'm using A and little a, and it really doesn't matter in the scheme of things what you're calling these, as long as you match them up properly. And then I've got C and little c. So I'm going to use this one and this one. Now the sine of A, that means I'm going to be taking the sine of 40, and I'm going to divide it by the length of A, which is 10. And then I'm going to take the sine of C, which is 70, and I'm going to divide it by C, which I don't know. And this is going to be a case of solving a proportion. And we've solved proportions. That's your cross multiplication and then divide when necessary. So I'm going to actually open up my calculator application so that I can show you how to do this on the calculator. So I'm going to open up the Inspire. And you can use Desmos if you choose to use Desmos. In fact, I might use Desmos here. I like using the Inspire because it's what we use in class, but Desmos is perfectly fine for this. So once the Inspire opens, if you don't use the Inspire, you can use an 84. It's all the same. What you need to make sure of is that you are in degree mode. And you can see right here that you can toggle that on the Inspire. Now, other calculators, you have to go to the menu and mess with settings. On the Inspire, you just turn it into degree. So let's go back and forth. I need the sine of 40 and the sine of 70. What I'm going to actually do so that I minimize my rounding error is I'm going to draw my cross multiplication. I'll be cross multiplying these guys, and then I'm going to be cross multiplying these guys. To minimize rounding error, you try to round as little as possible and use the technology as long as possible before actually rounding and reinserting values. So here's what I mean. The sine 70 times 10, I'm going to go ahead and put that into the calculator in one shot. So it's going to be 10 times, I'm going to go to the trig menu, I'm going to choose sine of 70, and that's going to give me 9.39693. Now, if you round that, it could throw your answer off fairly substantially. So I'm going to take as many decimal places as I can. And so I'm going to go 9.39693 because that's what it gives me. Most of the time, I tell my students, and if you're one of my students that's watching this, I tell you when you're doing trig ratios to go to 4 decimal places. So we're going to use all 5 of them, 9.39693, but I don't have to write them all out on my paper because I'm going to come back to the calculator and revisit that. So 9.39693. Okay. Now that is equal to sine of 40, this one right here, times c. Now I'm going to put the c out in front. And so I have it like this. You're going to solve this just like you would any other algebra equation where you're trying to solve for an unknown. C is my unknown, so I'm going to take whatever is multiplied by my unknown and divide both sides by that value. Remember, I'm solving for C, so I want that to be a 1C. So now I'm going to take that 9.39693 and I'm going to divide it by sine 40. So back to the calculator, I'm going to take this value, and in the Inspire, you can actually select and see how it extends it out. I'm going to divide that by sine of 40. And there's my answer, 14.6. So 14.6 is C, which means 14.6 is the length of my side. So C equals, and I'm going to round to 1 decimal place, 14.6. So that means in my triangle, this side is 14.6, and since my unit is centimeters, it's centimeters. That's how you use the law of sines to find a missing side. However, it's not always a side that's missing. Sometimes it's an angle that's missing, and we have to employ inverse trig. So I'm going to go ahead and give you another example, and we're going to go to another page. And I'm going to rewrite the law of sines up here for you. So we have sine of A over A equals sine of B over B equals sine of C over C. And I'm going to give you a triangle. So I'm going to give you a triangle here. And I'm going to say that, again, I'll label these as A, B, and C. Label them as you want. They're not always going to be A, B, and C, but for our purposes, we'll use those for the formula. So let's say that A is 30, and the side across from A is 7 inches. And let's say the side across from C is 11 inches. And I want to know what is angle C. Now that little symbol right there, remember that's called theta. That's something that we use to represent a generic angle. Basically, you can call it X, you can call it whatever you want, but the bottom line is I don't know the angle. Remember on the previous example, I didn't know the side. So you can see here, I knew the 2 angles and 1 side. In this example, I know 2 sides and 1 angle. So again, I'm using C and A. It doesn't matter. So I'm going to go sine of 30, which is my A angle, over 7 is equal to sine of C, because I don't know C, over 11. So I'm going to have to figure out what angle C actually is. Once again, we've got a proportion, so we cross multiply. do this one first. So I have 11 times the sine of 30. So I'm going to go to my calculator. I'm in degree mode. 11 times sine of 30 degrees. And I get 5.5. So it's nice and neat. So 5.5. So I'm going to go back. So that gives me 5.5 on this side. On this side, I have 7 times sine of c. Well, obviously, I'm trying to solve for c. So I want to get sine of c because it's a big expression altogether by itself. So we're going to do the same thing we did in the last example. I'm going to divide both sides by 7. So if I go back to my calculator, I'm going to do 5.5 divided by 7, and I get 0.785714. Now I'm just going to go to 4 decimal places this time. So 0.7857. So that gives me 0.7857 on one side and sine of c on the other side. When you are using trig and you are trying to find an angle, you have to use inverse trig when you're solving triangles. I'm going to take the sine and I'm going to move it to the other side, and it becomes an inverse. So I now have inverse sine, which some of you have seen it probably written as arc sine. That's the same thing. Inverse sine of 0.7857, and that is going to give me my angle. So I'm going to take the inverse sine of 0.7857, and since I have the calculator pulled up, 1/4, and I get 51.8. So what that tells me is that angle C is 51.8 degrees. And that is how you solve for an angle using the law of sines. So that tells you about the law of sines. I'm going to go ahead and talk about law of cosines in a different video, but hopefully this helps you out with the law of sines and helps you understand it better and when to use it.